Hello. I think I need to lecture on zero force members, uh, just because it is, important. So, the book tries to come up with a if-then set of circumstances that guarantee there's a zero force member. So I want you to read this chapter, try to understand it. So here we go. If a non-loaded truss joint is formed by three members, two of which are collinear, so that means they are in the same line. The third member must be zero force. So examples of that. So we're always talking about hinge joints. So if you have two beams that are members that are in line, the third is going to be a zero force. And there can be no reaction on this point, so there can't be any external force. Okay, so if the hinge has some sort of external load, then this is not going to be true because this is the only joint that will be able to absorb that load. And then if this joint has a reaction on it, then this third member needs to be able to absorb that vertical reaction there. So what it's saying is if there's just a hinge and there is no loading condition, there are just beams on it, and there are two that are in line, then any force that's coming through this hinge will just exit right out of this hinge. Whoop. And yeah, so that's one of the condition. That was condition one. Condition two, if a non-loaded truss joint is formed by two non-collinear members, then both of them must be zero force. So again, you have a hinge, and the important thing is that there is no external force or reaction on that hinge. There is just members there. So then there is no, these will both be unloaded. And so this idea becomes really important for some of the future ideas in the class for, strength of materials. I drew this bad, whatever. And I'll show you in a second. I'm just sort of just winging this and not being accurate. Okay, so there's another one here. Close enough. Kind of terrible. Okay. So yeah, this is book example 4.3, and they show you a truss, and they have a load condition and reaction conditions, and they say identify which members in this truss are zero force. And I tried to just crappily draw it. So what it really comes down to is where are your forces and where are your reactions. They place the reaction here. This is a roller. And then they also place the reaction out here. So when you're talking about members that are between the reaction here and the loaded, all of these members are going to have some sort of force on them. But if you can go out here, and there is no external load, and there is no reaction, So you think about this force as translating through the beam to the next hinge, through the beam to the next hinge, that kind of idea. And so if you can identify that there is a hinge out here with no load and there's only 2 on it, boom, boom, those are both unloaded. And then what's your other rule if you have... So like, for example, this is point D. It has 5 members coming out of it. So you're not going to be able to easily say that any of these are unloaded. They could all be interacting. Yeah, so G is in the same boat. He's over here. And he's got a reaction on him, so all of these are potentially going to have some amount of load, judging it by point D. So yeah, again, you're going to look at each one of these one at a time. Here's H. So H, you could call it pen or hinge. H has this condition. So if you remember, if you have 2 in line and 1 not in line, and there's no external forces or reactions on this point, then this one that's not in line is a no force member. So from just looking at point H and its loading condition, hinge H, you can tell that this member, GH, is a zero force member. So yeah, that's kind of what the book is doing. It's like, here's joint B. Just zoom in on joint B. And he said 2 of the 3 members are collinear, so the third one has to be 0 force. And this just reduces, for a complex truss like this, it reduces your workload. Wow, this is a lot. Yep. Wow, that is quite the chain reaction. So, I already said both of these are, so yeah, which point was this? I. Let's go hinge I. So because both of these are 0, and then this one is 0, this one is 0, you could infer that this other one up here is also 0. So now we have a whole bunch of zeros. H, I, G, there's an F straight above G connected vertically. There's an E connected straight to H, straight to D, C. Let's do, running out of room, so I'm gonna squish it. Sorry. Okay. And then this one has a load on it, so E must have some member on it that translates this load down to one of the reactions. And this one is a roller. So that's a vertical reaction, this is a vertical reaction, and a horizontal reaction. So the load here on the whole truss is horizontal. So this load must make it over to the horizontal reaction at A. So you could think about this horizontal load flowing through these horizontal members. And this member is vertical, so it's not going to be able to help with a horizontal load. I'll bet you that one's actually a no load. So just thinking about force flowing through members is pretty cool. So we already identified this one's hanging off. There is no force out here. There's no reaction out here. I, in this scenario, is really a dead weight. So then we already broke down hinge H. And I'm just going to do it again. This time I know this is a no load. And from our rules, we have collinear and the one hanging off is a no load. Now, since both of these are no load, the third must be. Like, there's not going to be a force on this hinge and no reaction against it. Right, so looking at G, he's got so much going on, I'm going to skip him. Let's look at F. So again, F looks exactly like H, where there's two collinear. And so that third wheel, with no force on it or reaction on it, that third wheel is going to be 0. And because both of these are 0, the only remaining one must be. So now we have what looks like enough information to say this one again. So 2 collinear. Oh, I already did that. Okay. Whoop. Now, if you look at G, it's not going to be eliminated because like I said, G is so complicated. It has all of these different force members on it, and then it also has a reaction, and that reaction can always transmit force through it. So it's really hard when you have a force member or a reaction member to focus in on that one and try to eliminate members. So, and in fact, from the book's rules, you're not going to be able to do that. So I'm going to leave this one as a potential. Ooh, there's also that one. Same with E. E has this arrow, a force in this hinge joint. So I'm not going to be able to just start eliminating members that have a force on them when a hinge has a force on it. So then in this scenario, you go maybe C, hinge C, and he has these 2 collinear and 1 vertical. It looks like there's definitely going to be a horizontal force in this member. So this is going to have some horizontal force component. But because hinge C itself is not a reaction or a loading pin, then this third member is not going to do much. So zoom in on hinge B now. And it's the same pattern. And I think it's the same rules because there's no force on it. So like that. So that third member is, but I do suspect there is a compressive force traveling through E to, no, it's not compressive. It's probably tension, but there's some sort of force traveling along this chord down to this reaction and potentially even through here. A has that reaction component. So I think right here I'm done. So I have a whole string of no load members because the support isn't over at I, it's over at G, which is a weird place to put a support for a truss. But it's just, I think they just did it to show you how to do this, really. So they put the support over at G instead of over at this end over here. And that doesn't really make sense to build, any kind of frame or scaffolding that way, unless you anticipated maybe there would be a load here out at the end, like a vertical load or something. But it did result in some pretty fun zero load members, which, you know, why would you build a scaffold with this many zero load members? Oh, wait, they identified ED. Why would they identify ED? Hang on. We conclude that DE is a zero force member since BD, CD. Oh, because there's no vertical component? Oh. Well, that's good. I looked at the book. Alright, yeah, let's just do it on here. So D has a horizontal hinge, horizontal, vertical, and these are all 0, 0. So when you look at like maybe the sum of forces and the y, so like even if you didn't identify this member was going to be 0, you would, when you did all of your math, you would find it. You just did a little extra work. So it's not the end of the world if you don't catch every one of them. So yeah, you've got a vertical force C, then you've got some angle component on BD, so BD in the y direction, and then DE in the y direction. So from this 0 member identification, you're just saying these are 0. So sum of forces in the y. So you would end up with something like that after you did after you went on to solve, you would end up with DEY equals 0, because you would just look at, you know, sum of forces at each hinge. Cool. And I think that is my lecture on method of joints. And now I'm going to move on to sections, which is meat and potatoes. All right, see you in a minute.